Before I give this, there is one, yesterday I thought of giving, I forgot, there is one function which is available and it is used to convert a decimal number into binary. So that will be handy for the students who are not much aware of the binary number system. So I'll go for this and open the file. So this file is this batch file. So day 1, day 2, day 3. Now day 4 we are going to start the coding. So day 4. Now there are some library functions. I can say if I take some number, we have seen some numbers here. Yesterday I gave you some numbers which I converted into binary. We'll take the same numbers. Like I 37, which is 001000101. So we'll take print binary bin of 37. So it will give the binary conversion automatically. It says 0B, something like that. So if you want binary conversion, you can get it, but there is small problem with this. Problem means the way it displays is slightly different. So when I take this, it will match surely with the whatever value we have mentioned here. So this is so this is 100101. It is matching. So that is not a problem. The problem is when it is a negative number. So when it is a negative number, what it will give is, it will not give the exact binary equivalent. It will say minus, but minus is not stored separately here. So it gives 37 only, but minus it will give the symbol. But actually internally it is represented as represented in 2's complement form. So you can convert a decimal number into binary directly with the help of bin function, but the negative numbers, it will just add symbol minus, but internally, as I told you, it is represented in 2's complement form. So if you want to have a negative number to be represented in binary form, take suppose if I take here 42. So the 42, I'll get it as like this. So which is 101010. So here I think we have given 10101042. Yeah, 10101042. If I want a negative number, take this positive number, then find 2's complement. So find 2's complement and represent. But Python will not give direct 2's complement. Suppose if I say minus, it will give minus symbol, but not 2's complement. Okay, that is one limitation here. But internally, everything is 2's complement. But this is Python way of displaying binary, negative binary numbers. Now you can also find the hexadecimal equivalent. Suppose if I say 100, so 100 is I think 64. Is it 64? Yeah, 64 in hexadecimal. So 0x indicates that it is hexadecimal. 0b indicates that it is binary number. So you can also find hexadecimal number, and you can also find octal number. These are actually built-in library functions. I gave library functions as several types, 3 types basically. One is built-in functions, another is built-in modules. So we have seen some built-in function like bin is a built-in function, hex is a built-in function, and oct is also a built-in function. So if I take the 100 in octal form, it is one. See, 0 O, 0 O represented is octal, 0x represented hexadecimal, 0b represented it's a binary number. So this is not 0, this is not 0, this is O. So 0 O, 100 is 144 in hexadecimal octal form. So this is how we can get the conversion directly. But with negative numbers, I told you, it will add simply the negative sign, but internal representation is not there. So that is one help you can get from Python in conversion. Then we'll go for the bitwise XR. So when you take bitwise XR, the symbol used is caret symbol. This is the symbol used for bitwise XR. Now when I take bitwise XR, so if I take like A XR B, like every bit of A is XOR with the corresponding bit of B, like ANDing and ORing. Now when I take a bit B, bit of A, some bit of A and corresponding bit of B, then 0 0 0 1 1 0 1 1. So now the result of this XOR operation is if the bits are same, the result is 0. If bits are different, the result is 1. Bits are same, 1 1 0 0 0 0. But this rule is applicable only when it is applied on 2 bits. Now normal XOR rule is whatever inputs you have. So here 0 0 is one pair of input, 0 1 is one pair of input, 1 0 is one pair, 1 1 is another pair. Suppose if I take 5 inputs, something like this, I want to XOR all these 5 bits. Now whenever I have a number of input bits, there are 5 bits. Now count the number of ones. So if the number of ones are odd, then the output is 1. Number of ones is even, the output is 0. So here number of ones are odd, so output is 1. Now in this case, number of ones are even, so 0. Number of ones are odd, 1. So number of ones are odd, 1. Number of ones are even, 0. So this is the rule applicable for any XOR operation. But if it is 2 bits, you can say if they are same, it is 0, different, it is 1. But suppose if I take 3 bits here, they are same, but the result is 1 because the number of ones here is odd. So this is the rule for XOR operation. Find the number of ones. If the number of ones is output is 1, otherwise the output is 0. So that is the logic for bitwise XOR operation. I'll take the same numbers like I'll take same numbers what we have used. Like suppose A is 37, B is suppose 42. So we can take anything. So A 37. Okay. We want A equals to A XOR B. So A is 37 means 0 0 1 0 5 0 1 0 1. This is 37. 42 is 0 1 0 1 0 1 0. So this is 42. Now if I perform XOR operation 1 1 1 1 0 0 0 0 because same. So the output is 15. So this is 15. 15 will go into A. So that is bitwise XOR operation. We'll check that. So A equals to 37. B equals to 42. I want A equals to A XOR caret symbol. Sorry, that is the caret symbol. Yeah, caret symbol B. B equals to 42. Now print A. we'll get 15 here. So we'll get 15. So that is bitwise operation. So if the numbers are different, one, same, zero, same, zero. Same, zero, same, zero. So that's why you are getting 15. So that is bitwise XOR operation we performed here. And next, we'll see the next bitwise operator, which is ones complement operator. So next, we'll see ones complement operator. Now, the first thing, first property of this is it is unary operator. Unary operator. And the symbol is tilde. So it is applied on single operand. So this is variable, single operand, not like bitwise AND, bitwise OR, bitwise XOR. They are applied on two operands. Here it is applied on one. Suppose I can take this one. So A equals to tilde A. Suppose A is 37. What it does is it will take the number and every bit is converted into complemented, because it is one's complement, every bit is complemented. This becomes 0, this becomes 1, this becomes 0, 1, 1, 0, 1, 1. So because MSB is 1, this is going to be a negative number. So this is going to be a negative number. If I want the value of that number, you have to find 2's complement of that. So if I take 2's complement of that, this is a negative number because this is this 1 indicates that it is negative number, indicates it's a negative number. So when it is negative number, to get its value, we have to find 2's complement. Its value, find 2's complement. So when I find 2's complement, this is 0, 1, 1, 0, 0, 1, 0, 0. So if I take this, this is 32 plus 6, 38. So it is minus 38. So what you have to do is, when I want to find one's complement, the result, take the value, add 1 to it, then change the sign. So that's how directly you can get. So here, if I take A again 37, A equals 37. Now I want A equals to tilde A. So print A, I'll get minus 38. A, so I'll get minus 38. So that is how you get it. Suppose if I take minus 40, what should be the result? Directly, if I actually we have to take one's complement and do it. So minus 40, if I want one's complement of that, first add 1 to it. So if I add 1 to it, it is minus 37. Then change the sign, so it is 39. So if I take minus 40, I'll get 39. So that is how you can directly do it. If this is the always correct method, take the value, take one's complement, but check MSB. If MSB is 1, it is negative number. Finds 2's complement to get its value. If MSB is 0, it is direct number. So that is one's complement operator available in Python. So that is next one. The last two operators, bitwise operators, or last two bitwise operators are left shift, and right shift. So left shift is 2 less than symbols. So this direction indicates it is left. So what the syntax of this is, means how to use this is, so some operand, first variable operand, operand 1, operand 2. what this does is this value is shifted. This value is shifted left this many times. OPD 2 times. So value here means OPD 1 is shifted left, OPD 2 times. For example, suppose if I take A as 37, if I say A less than 2, shift A towards left 2 times. Every bit should be shifted left. Every bit should be shifted left 2 times. So when I take suppose A37, now A37, so 37 suppose if I take the result as A equals to A left shift 2, then first take value of A is 0, 0, 1, 0. It is actually several bits. I'm taking this as there will be several bits. I'm taking 8 bits, last 8 bits, 0, 0, 1, 0, 0, 1, 0, 1. Now, if I shift each bit towards left, what is going to happen is now this will come here. This is shifted here. So this becomes 1. This becomes 0. This becomes 1. So to be clear, I'll write a better way so that you can follow it. So I'll take a square so that it will be easy for you to follow. So I'll take, this is first one, second one, third one, fourth, fifth, 6, 7, 8, 9. Okay, I'll take for simplicity 9, but it will be any number, several bits present. I'll take one more here. So I'll take, this is this one here. Now when I shift left, this bit will come here. 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 This comes here. This comes here. This comes here. And this is dropped. MSB, this MSB is dropped. And this is filled with 0. Filled with 0. LSB is filled with 0. So this is, suppose 37 if I take. So it is 37. So this is 0. 0. This is 1, 0, 1, 0. So this is 0, 1, 0. This is so this one will come here. This one will come here. This is filled with 0. This 0 will come here. 1, 0, 0, 1, 0, 0, and it is dropped. So this is shifting happens. Now shifting, one point to note is shifting a number towards left. Shifting a number towards left one time is equal to multiplying it by 2. Multiplying it by 2. So now actually this is, you can take this as 74. Now if I shift it again, because we have to shift twice, so 0 is filled here, this 0 will come here, this 1 will come here, 0, 1, 0, 0, 1, 0. So this is nothing but 148. If you want to check this, so this is 4, This is 9, 144 plus 9 is 148. So you can check that. So I'll take A 37. A equals to 37. Then A equals to A left shift 2 times. Then print A. So it will become 37 into 2 is 74 into 2 is 148. So you'll get 148 as result. So shifting a number towards left is equals to multiplying it by 2. So that is shifting left. This is shifting left. Next, when I shift it right, it is same, but there is slight difference. I'll give you what is the difference. So when I take right, so this is shift right. This is shift right. So shifting one time, shifting a number one time is equal to dividing it by 2. Dividing it by 2. That is integer division. Dividing it by 2. So if I take A 37, A right shift 2, A equals to A right shift 2. So here the important thing is the important thing here is anything. Suppose if you have something, you please keep it in the chat box. Something wanted to say, somebody wants to say something. Okay. So if I shift here, the important thing is when I take a number, when I shift a bit towards right, this is LSB is dropped. LSB is going to be dropped. LSB is dropped. Remaining bits are shifted. So this is shifted here, this is shifted here, this is shifted here, this is shifted, this is shifted, this is shifted, this is shifted. Here, instead of filling with 0, 0 is not going to be filled. MSB is going to be retained. This is one major difference between left shift and right shift. MSB moves to the next bit and MSB is going to be retained. That is one very important thing to note. It is not filled with 0. MSB is going to be retained. Okay. So if I take 37, so 37 is 0. So it is 0, 0, 1, 0, 0, 1, 0, 1, 37. If I move once, first time if I move, so this is going to be dropped. So this 0 comes here, this 1 comes here, this 0 comes here, this 0 comes here, this 1 comes here, this is 0, and it is going to be retained. So this is actually 37 by 2. Again, if you shift it, this is 37 by 2 is 18. So again, if you shift it, so this is going to be dropped. This 1 comes here. This is 0, 0, 1, 0, 0, 0, 0. So it is 9. So when I take 37 and shift twice right, so A equals to 37 and A equals to A right shift 2, then print A, then I'll get 9. So that is the right shift. That's about bitwise operators. So that is about the bitwise operators. And bitwise operators, or we have completed all bitwise operators. If any doubt is there, I'll give you in the end. So that is about bitwise operators. Next, we'll see some built-in library functions. Built-in functions. Already we have seen some. I'll go to new one. That is better. Okay. So built-in functions, we have seen some built-in functions. So we have already seen bin is one function which is to convert decimal into binary. Hex is to convert decimal into hexadecimal. Then oct is to convert decimal into octal. Now we have some more, like suppose there is a max function. If you give a set of numbers, it will give maximum of numbers, whatever you mentioned. Whatever you mention, it will give this maximum of that. So that is one more function. It is very useful function. So when I take print maximum of suppose 10, 47, 93, 22, -5. I can take any set of numbers. You can take any set of any number of numbers. It will give the maximum of that numbers. Now, same thing. If I use minimum, there is a min function. It will give minimum of that numbers. So there is min function. These are all built-in functions. Min present. So it will give minimum of that -5. So this is one more. And one more function which is very frequently used is input. So this max we have seen. Before we go to the input, there is Pow function. It is used to find x power y, which is also same as x double asterisk y. So there is Pow function, and you can also use operator. So I can use here Pow means power. This is there in C also, 10 power 3. So 10 power 3 is 1000. So it will give 1000. This is equals to 10 double asterisk 3. So both are same. The difference I'll give you little later, not at this stage. So I'll give you the difference little later. There is a small difference. I'll give you later. So it is same as power operator double asterisk. Now we'll see one function which is input function. There is an input function. So what it does is it reads data from keyboard. So it reads data from keyboard. So that is actually the input function. It is very useful function. Generally, we read data from the keyboard to perform some operations. So when I take n equals to input, if I keep it, if I exclude this, it will wait for you to enter something. So it is waiting for you to enter something. Suppose if I enter 100, so it will read 100. So I'll print 100, print n. So it will read 100. I've entered 100. So I'll print 100. So I'll enter 100. I'll print 100. So that is input function. Now this input function, because when I say input, here when I say input, it is waiting for us, but we don't know what is happening. But better way of doing it is, I'll enter 50 here. So better way of doing it is always attach a message. Enter a number. Enter an integer. Okay, integer. I'll say enter an integer. Now with message it will wait. So it says enter integer and it will wait. Now I know what to enter. So I'm entering. So I'll get 100. But one important thing here is whatever you suppose if I take 100, I want to print suppose, whether it is I want to divide it by 2. I want to divide it by 2. So when if I divide it by 2, I should get 50. So I'm entering 100 here. So it is giving error. It is giving error. Why it is error is the important thing is when I enter something. When I enter something here, whatever you enter, whether you enter integer or real number or series of characters, whatever you enter, so in this, it will read the data. It will read entered data as string. As string means suppose if I enter 100, it will read it as a string. Anything which is kept within double quotes or single quotes is considered as a string. Now check that. So I'll remove this statement. I'll remove this statement. So now print n, and also we'll check what is the type of n. So whatever I enter, it will be available as string. So if I enter 100, it says it is string. Now if I enter 1.23, it says it is string. Now if I enter hello, it says it is string. So if I enter some complex number 3 plus 5j, it will say it is a string. Now if I enter whatever I enter, it will be taken as a string, collection of characters. So I can mix suppose A 1, 2, 3, 4. I can mix alphanumeric. Suppose CD. CD. I can say dollar asterisk, whatever star here. Whatever I enter, it will read it as a string. So it will read it as a string. So that is the property of input. But when I want to do some arithmetic operation on the data what I have entered, I must convert it to integer. So what input function does it reads data from the keyboard, and it will read the data whatever you enter in the form of a string. So if I want integer, after I read it, I must convert it into integer. If I want real number, after I read it, I want to convert into real number. Like suppose if I take now, this is saying n type n. Now if I write n equals to int n, I'm converting that into integer. Now if I print this, so now if I print this, it is it will do that number as integer. It will give that number as integer. So 100 here. So first what it gives 100. Then later when I convert here, when I convert into integer, so it is converted into integer. So there are several functions. This is int to convert data in other form, actually integer data in other form. What is that? This mean I'll give you other form into integer. Now why I am saying like this is, so it will convert only if the data is integer. If you try to convert the other data, it will not be converted. Now I'm entering 100. When I enter 100, 100 is available like this. So when I apply int on this, because whatever inside string is integer, so this will be available as integer. Now if I enter 1a 0, now this is not integer. This is not integer. If I try to apply int on this, it gives error. It gives error. So that's why integer data available in other form. So that's why I told like that. Now if I execute this, Now A1, 2, 3. Now it S1, 2, 3. It is not actually integer. It is alphanumeric. So if you try to convert, it will give error. First, it will read it as a string. It says, I cannot convert whatever present. This I cannot convert into integer because it is not integer. So that is one thing you should note when you apply the conversion types. So you can convert. There are different functions. Now, once I convert, I can perform whatever arithmetic operations I want. So I will perform n by 2. So now I'll get 100 by 2, 50. So when I say 100, it will convert. Then print spelling mistakes here. Print spelling mistake. So print. So I'll exclude this. Now if I say 100, so now it is converted into integer because it is a real division. I'm getting 50.0. So similarly, there are several other functions to convert data in one form to the other. Now suppose if I have some data, real data in the form of a string. Now if I want to convert this into real number, I have to say float. Then it is converted into float. So when I take this, same thing I'll take and copy it here. Now I'll enter floating point number. So if I exclude this, so 1.23. So sorry, it is 1 comma I have entered. It should be 1.23. So 1.23. So when I enter 1.23, 1.23 is sorry, here I should say not integer, float. Mistake, float. So I should say float 1.23, whatever it is. So now if I enter, so initially it is string, later it is converted to float. So you can convert into other form. Similarly, now I want 100. This string will about string ladder. I want 100. I want to convert into string. 100 to be converted into string. What I can do is I can say str100. Now this will be converted into string. It will be converted into string. Like suppose if I take n equals to 100. Now print comma type of n. Now I want to convert that into string. So I can say n equals to strn. Then I can say repeat that statement, print n comma type n. So this is the opposite conversion. We converted string into integer. Now integer to string. So this has become string. So these are the built-in functions which are used to convert. So we have seen several built-in functions. So we have seen several built-in functions like bin. We have seen hex, oct, max, min, pow. Input, very frequently used function to read data from keyboard, but its limitation is it reads the data in the form of a string. Then the conversion functions, int is one conversion, float is another conversion, then string is conversion. There are several conversion functions available in Python. So these are conversion functions. So these are built-in functions. Some built-in functions. Now I told you the functions, the library of Python. Library of Python is one category, one division. One type of division is built-in functions. Built-in functions. Another one is built-in module. Built-in module. Now this is readily available. I am straight away using readily available. So I can use straight away. Now this module is a bundle. It is a box. So there are several functions inside it. if I want to use this module, I cannot straight away use that. There are so many, it's a bundle or box. What we can say is there is a bundle or box. This is a module. There are several functions, function 1 inside it, function 2, and so on. Now, if I want to use this built-in module, these are independent. So int is directly available. I can use. Input is directly available. I can use. It is not kept inside a box. It is freely available. Now, when I say module, it is packed and kept inside a box. Module, you can assume it as a box. If I want to use this functions available, you have to open the box. How to open the box? Import module. Import module. Then if I want to use the function 1, take the module name dot function 1. Module name dot function 1. Now, one example for the frequently used module, one example for frequently used module is math module. So math module. So this contains so many functions like trigonometric functions, sine, cos, tan is there. Then some functions like e power x is there. Then log x is there. Then log x with base 10 is there. Then there is ceil function. What is that ceil function? I'll give you. There is floor function. These are some functions that are there. So there are several functions as part of this math module. Now, if I want to, because it is math bundle, it is a module. So it is a box. Module is a box. So because it is inside a box, I cannot say sine. It is not available. I cannot use this because it is inside the box. So first to open the box. How do I open? Import math. Then if I want to use sine, sine of an angle, so I have to say sine. Now there is radian is also there to convert degrees into radians. There is degrees is there to convert radians into degrees. So these are the functions, but they are bundled in a module. So if I want to use a function, I have to first open it with the help of import, then use it. So this is the difference between function and module. So I'm using all functions. I'm using print. Print is also a function. Input is also a function. Float is a function. Int is a function. I'm straight away using. Now, if I want to use, suppose I want to use sine, which is sine of some angle. So angle must be given in radians. Suppose if I take 0.5, I cannot use it. Or first, I'll try to convert degrees into radians. I want to convert some 45 degrees into radians. Now I cannot use this. It is an error. So it is an error because radians is not a built-in function. It is a module. So I have to open the module with the help of math. Then now, after I exclude this, now I can use the functions that are there inside the module. Now I can say math dot radians, which converts degrees into radians. 45 degrees I want to convert into radians. I think 45 is 3.14 by 4. So it is 0.78. So I'm getting now. So when I try to use radians directly, it is not giving. So this is the difference between built-in module and built-in function I gave you in the beginning. So there is a radians function inside the module math, which converts degrees, 45 degrees. Suppose if I take 180, it is equals to pi. So 3.14 you get. So 3.1415. So it converts 180 degrees into radians. Now, when I take a trigonometric function, math.sine, I should give the angle in radians. So if I give 45, it will not take, it will give some result unexpected because it will take that as a, take it as a radians. So what I should do is convert into radians. So 45. Now sine 45 is I think root 2, then 1 point root 2 or I don't know, 1 by root 2 I think. So it is you will get sine of 45 degrees. First I am converting it to radians and then I am finding. So I can find math dot cos of math.radians, then 90. So I can find this is some very small value, or I'll take 60. I think 60 is half. I don't know. Yeah, it is half. So cos 60 is half, 0.5. So I'm getting 0.5. Then I can also use tan of math.radians 60. So whatever you want, you can find. So these are module functions. Then I can use e power x. So if I want to use e power x, math.exp. So suppose 0.5. So it is e power 0.5 I'll get. Then reverse of this is log. So math.log. If I take this value, I should get back 0.5 because it is reverse. So log, this is log of this value. So I should get back that 0.5. So we are getting 0.5. So this is log with base e. Now, if I take log with base 10, so I have to say math.log 10. Log 10. Suppose if I say 1000, so I'll get 3. So 10 power 3 is 1000. So log 10, I'll get 3. So what are the other functions? So you can convert log 10 we have seen, radians into degrees, degrees into radians. So if I take math.degrees, so 3.1415, 3.1415. So I should get roughly 180 degrees because I may not be giving the degrees here. So I am not giving the exact values here. So I get roughly 180 degrees. So 179.99 because I am not giving, I can give the constant which is available as pi. I think it is available. So now I'll get 180 degrees because pi is equals to, I can print math.pi. So pi value is 22.7, so which is this value. Now, when I take this floor and seal, I'll give you what is floor and seal. If you are C programmer, they are there even in C. In the same way, whatever there in C, in the same way they are available. Now, when I take seal, seal is ceiling, floor is floor of the room. Now, when I give some value here, a real number, I have to give a real number. Here also, I'll give a real number. So what it gives is, it finds smallest integer greater than value whatever that this gives, finds largest integer less than value. So this is equals to, now if I take, it is like a double slash. What it does is it will give the same thing. Now when I take, suppose if I take math.floor, if I say 3 point or 4.1, so it will give the smallest integer, largest integer less than this. It gives the largest integer less than this. So what is the largest integer less than this is 4. So that is actually floor. Now when I take negative value, I take minus 5. So the largest integer less than this is minus 5. So we'll get -5. Now, when I take seal math dot, now I'll take same 4.1. So it will find math dot seal, CILTEIL. So it will find the smallest integer greater than this. So smallest integer greater than this 5. Now, when I take the same thing, negative value. So minus 4.1, smallest integer less than this is -4. So -4. So smallest integer greater than this is -4. Greater than this value is -4. So that is here the seal and floor. That's about module and the functions inside the module. So if it is a built-in function, it is readily available. If it is a module, it is a bundle. So because it is inside the bundle, I cannot directly use this. It is packed and kept inside a bundle. I cannot use it directly. I have to open the bundle, then use it. So that is the module. So we have seen some library functions and one module, and we'll be learning part of this course. So that is about the library functions and library built-in functions and built-in module. Next topic what we are going to learn is control structure. Control structures are actually simple thing in any language. So I'll start the control structures. When I take control structure, normally when I take a program, whatever I have, it is collection of statements. So there will be statement 1, 2, 3, 4, 5, 6, 7. This they'll be there. Now, when I execute these statements, they will be strictly executed in the order in which they are present. So first one is executed, then it will go to second one, then third one, fourth one. The physical order in which they are present. So this is normal execution. Normal execution. Now control statement, it is structure or statement. Control structure or the statement is the one which changes this normal sequence of execution, which changes the normal sequence of execution. Normal sequence of execution. So this changes the normal sequence of execution. So normally the statements are executed one after the other in the order in which they are there. But control statement or structure is the one which changes the normal sequence of execution. Now in Python, there are almost similar control structures that are there in C. So if I take Python control structures, the control statements in Python, one is if is one control statement, then loops are one more control statement, and then the break is one control statement, then continue. These are the control statements that are there in Python. So 4 types of control statements. If is one, then loop is another one, break is third one, and continue is the fourth one. So these are the control structures, and we'll learn each one of them. First, we'll start it with if. Now, if the control structure has several types. One is simple if. Simple if. Then second one is if else ladder. If else. That is if else. Then third one is if else ladder. And you can also take nested if. Okay, I'll also take nested. These are the different if statements present. First, we'll take simple if. because these are very common things and very simple. So I'll be running through them very quickly. So first, if I take simple if, so every statement will have a syntax, means the rule to be followed. If some expression, then colon. This is important part of the syntax. Now, normally when I take Python language, it uses indentation. Indentation. That means normally when I take statement, suppose A equals to 10, B equals to 20, C print C, we are using statements at the same column. So same column. Now, if I want to keep one statement inside another, then I have to give a gap. Now I want to keep one statement inside if, so I have to give some indent, which is generally a tab space. One space or two spaces tab space, then I'll keep some statement. Statement one. So this is very important in Python. In C language, there is no indentation concept. There is a bracket concept. Here, there is no bracket concept. There is indentation concept. So what actually happening here is, first expression one is evaluated. This is checked, evaluated. If it is giving true value, if it is true, then the statements which are kept inside if are excluded. If it is true, they are excluded. False, they are skipped. So this is if only, if and only if this is true, exclude this set of statement. Otherwise, don't exclude. Now, when I take here one example. Now I have n. I'll take n equals to 100, or I'll read it instead of n. I'll read and because it is it needs to be converted. I want integer, so I'm reading and converting. Now, if n is greater than 100, I want to add 100 to it, 50 to it, then print n. Otherwise, I don't want to do anything. So now, next print, suppose n. I want to just print n here. If I normally what happens here, when the first the condition is checked, if this is true, these two statements which are part of if, these two statements are inside if. How I am saying they are inside if? Because they are maintained with some indent. Now the next statement, I am starting from the place where if is started. Now if this print n is not part of, suppose instead of n, what I'll do is, I'll say hello, some hello here. Now the print hello is not part of if, because it is not maintained with indent. Now if I want to make this print as part of if, I have to give a tab space. So that is one important thing. So it will be clear when we write the code here. So first we'll write some heading here. The heading is control structures. Control structures. So in the control structures, first we are learning about if. So this can I take test. So I'm taking control structure. Within that, I'm using if. So simple if is one thing I have to use. So if I use simple if here, I can take I'm n. I want to read as integer, so I want to read integer, but because it is read as string, so after reading I am converting. So this is this statement, whatever I am writing, if you have confusion, this is equals to n equals to input. So I'm reading as a string, then n equals to integer. So I'm doing both of them together. I'm combining both of them. So that's what I have written. I'm reading integer as a string, then converting into integer. Then I'm checking if n greater than 100. So I'll add n plus equals to 50. So adding 50 to n, then print n. Otherwise, what I'll do is I'll print hello. Simply I'll print hello. Now, this two, because there is a gap maintained between this, one important thing is there is a colon. This is very important. Otherwise, it is an error for if you have to use a colon. Now, these two statements are part of if because there is an indentation. Now, print is not part of it because it is started with the same line. Now, I'll execute this. I'll give 200. So because it is greater than 100, 50 is added and 50 is printed, then hello is also printed. So 50 is added and 250 is printed hello. So this is now when I execute this, now if I enter 100, because it is not greater than 100, these two statements are going to be skipped. Directly it prints hello. So that's what happening. Now, if I want to make this part of if, so what I have to do is I have to say print hello. Now, when I say 200, it will print add 50, print and print hello. Now, if it is 100 or less, nothing is printed because now hello is part of if. So that is very important thing. When I maintain indentation, it is part of the statement. If I don't maintain indentation, it is in the same level like the statement. Now these two, three are with the same level. Now this statement and this statement are with the same level because the indentation is same. Now if I remove this indentation, now n equals to this statement if n greater than, and these are three are at the same level. Now print hello is not part of if. So that is if, simple if we have used. So if the expression is true, then those set of statements will be executed. If the expression is false, the set of statements are going to be skipped. So that is simple if. Next, the next type of if we'll see. Next type of if. If else. The next type of if is if else. If else. The syntax of this is if expression colon means some condition there, statements, statement 1, 2, and so on, then else colon. Now the important thing is these two should be at the same level, same place they have to start. Now statement 1, 2, 3, and I may have further some statements. Statement X. Now this statement X is not part of else, not part of if. Now these statements are part of if. These statements are part of else. Now if the expression is true, if this is true, then this part is going to be executed. This part is going to be executed. if the expression is false, this part is going to be excluded. So only either if part or else part is excluded. After excluding this, suppose if expression is true, the if part is excluded, then it will exclude this. It will not exclude else part. Only if part, then it will come here. If expression is false, only else part, then it will come here. So that is if else statement. So if expression is true, one set of statement. If false, that is else block, and else block is excluded only when the expression is false. So for example here, so I may read n equals to input. Now I'll take if n percentage 2 equals to 1. That means if this is an odd number. So here I'm writing some remarks here, which is a comment. I'll give about comment later. This is odd number. So here colon I have to give. Colon I have to give here. So this I'll remove. So if it is odd number, I'll say print n is odd. So I'm keeping only one statement, else print n is even. Is even. Then end. I'll say end. So I'll execute this. Here there is. So I have to enter here. Suppose if it is 100, so the condition is false. So when condition is false, it will execute the else part. So the else part is executed. Then afterward, whatever is there, that is executed. Now, if I say suppose 77, now if part is executed because it is true. So it is odd, then it will come to end. So that is if else logic. These are actually simple logic, so I'm going little fast because it is common across all the languages. Any language you take, it is safe. But here, the indentation is important. So if I want to add one more statement as part of if, so if it is odd, I want to add some 10. If it is even, I want to subtract 10. So I want to do this, then I want to print n after that. So now n plus equals to 10 will come under if, and n minus equals to 10 come under else. So I'll say suppose 100. So it will say n 100 is even, then it will subtract 10 from it, then print n value, which is 90. So because it is false, it comes here, it prints n is even, then it subtracts, then print n and end. Now, if it is even, suppose if it is 101, what it is doing it says end odd, then add 10 to it, then print n, print n. So add 111 and end. So that is if else control structure. So that is one more thing, a simple thing. Next, there is if else ladder. The next one here in the control structure is if else ladder. So if else ladder means here series of expressions. If expression 1 statements, then else if expression 2 statements, else if expression 3 statements, and so on, else, and so on, can have at the end else. So what this does is, so first it will check this expression. If expression is false, expression 2 is checked. False, expression 3 is checked. When one of the expression is true, then the corresponding statements will be executed. Corresponding statements will be executed. If no expression is true, then the last else block is executed. That is if else ladder. It is simple logic. Here what I will do is read total marks. This is the question. Simple question only. Because we are still in the beginning. Write a program. Write a program to read total marks of a student. This is first thing I want to do. Then display class of the student. Using the following rule. Rule is total marks less than, suppose 1000 I am taking, 1000 total marks I am taking. If it is less than 350 or if it is greater than 750, I have to say class is distinction. Class is distinction. If it is greater than 750, not 450. If it is greater than 600, means in between 750 and 600, it is first class. First. Greater than or equal shall make. Then if it is greater than or equal to 500, I have to say it is second. Now greater than 400, I have to say pass, just pass. Then otherwise, if it is less than 400, it should be fail. It should be fail. So this is, we can use it with ladder if. This is the question. Say I'm mixing this with text. That is one advantage of Jupyter Notebook. Okay. So this is the question I have. I'll share this file later because I'm writing daily some code. It will be useful to you. I'll keep it. It is available in my Google Drive. It will be shared. So I'll write. First, read the total marks. Total marks equals to int input enter total marks in the range 0 to 1000. So total marks should be in the range 0 to 1000. Then check if total marks greater than or equals to 750. So that is one first condition, first expression. So print distinction. Then next is else if total marks. This is second condition, second expression, greater than or equals to 600. Colon is must for everything. So print first, else if total marks greater than or equals to 500, print second, then else if total marks greater than 400 equals to 400, it is print pass. Then suppose if it is not any one of them, last else block, which is it prints fail. So this is called as ladder if. Now I'll exclude this. So I'll give 650. It should give me first. So it is giving first. So some here should close this. So I'll exclude this again. So it is saying enter total marks in the range 0 to 1000. So I'm entering 650. So it should give first. Now, if I say, suppose 800, so it should give distinction. Sorry, some mistake. 800. It should give distinction. Now, if I exclude this again, suppose if I give 350, it should say fail. So it is saying fail. So what it is doing is first it is checking this. If not, if this is false, it checks this. If false, it checks this. Suppose if this is true, then it excludes this. Then after that, it will come back to the last one here, whatever we are writing. Suppose we can say end of the program. The above one is class of the student. So now I'll exclude this. So suppose if I say 550, it should say second, and it says the above one is, finally it come to the last statement, the above one is class of the student. Again, I'll exclude. Now if I say 700, it says above one is, first above one is class of the student. So that is ladder or if else ladder. So we have seen simple if else and ladder if. Nested if we'll see in the tomorrow's class. And if you have any doubts, you can ask me. Till now, like library, modules, functions, we have seen. Then what else? Bitwise operators. Suppose if you have worked on Bitwise operators yesterday or today, and if you have any doubt on Bitwise operators, then control structure, if else. If you have any doubt, you can please ask me. Otherwise, we'll conclude. I'll give some 2-3 minutes time. So if you have any doubt, please ask me. I think these are very simple things.